Hello and welcome back to another video where today we will be deriving a cubic polynomial expression in terms of the compressibility factor z from the generic cubic equation of state. And right now you can see on screen are our starting materials, which is the generic cubic equation of state and two expressions, q equals a over brt and beta is equal to bp over rt. And these are just expressions that we'll be able to plug into our equation, clean it up a bit, and allow us to get to a more presentable cubic polynomial. So, how do we start? Well, we first say that, recall that the compressibility factor is z equals pv over rt. So we'll want to get the left-hand side of the equation to match that, right? But we still want our expression to be algebraically equivalent. So we'll say that PV over RT. And how do we get that to match? Well, since, let's get that laser pointer, RT is in the denominator, we'll want to make sure the denominator of each expression has an RT. And since V is in the numerator, we'll want to make sure that each expression in the numerator has a V. So why don't we do that? Well, first, RT divided by RT is 1, so we don't need to worry about that, but we'll have a V up here. V minus V over B minus, and we'll keep the terms in the numerator for now, A times V over RT all over V plus epsilon B V plus sigma. That's a bad sigma. Sigma B. Alright. Now, what's the next step we want to do? Well, we see a lot of v's in this expression. So, how are we going to deal with that? We can deal with that by still following the rules of algebra, right? Dividing both the numerator and the denominator by v. Okay? And that's equivalent to multiplying each term by 1. So, we're allowed to do that. So, let's move on. We can now call the left-hand side of the equation z. So, z equals 1 over 1 minus b over v, okay, minus a over rt all over 1 plus epsilon b over v 1 plus sigma b over v. Right? Okay. Now, when we look at this expression, what could be the next step we can take? Well, recall that z is equal to pv over rt, right? And we still have some v's in the expression. So let's move the expression around and see if we can get that equivalent to v. We can now say that z, or rather, let's see, z rt over p is equal to v. Oh dear. Okay, so let's see what happens when we plug in that expression for where we see v. So we can now say that z is equal to 1 over 1 minus b p over zrt minus, one thing that I forgot to mention up here is that here we should divide by v twice, right? Because if we only divide by v once, we can only get rid of the v in one of the two multiplied quantities. By dividing by v twice, we'll be able to divide by each term here by v and each term here by v. But in doing so, we will generate a v term right here. Okay? It just hit me. Not allowed to violate the rules of math, right? But now that we have that v there, we can now plug in the expression zrt over p into the numerator. And what that's going to look like is p. Oh, we'll keep the a first. A p over r squared t squared z. Right? And now you might be looking at this and thinking, wow, we are getting really messy. That's where these two terms come in, but we'll get to that in just a second. We now have 1 plus, let's see, epsilon beta, not beta, epsilon b p over zrt times 1 plus sigma b p over zrt. Okay, now this is where we can see these expressions I mentioned earlier becoming useful. Notice that beta is equal to bprrt. Where can we see that? Right here, and right here, and right here. So let's go ahead and plug that in. Excuse that. I should silence my phone before recording these. We can now say that z is equal to 1 over 1 minus beta p over z. Okay? Minus, now, how are we going to clean up this nasty irrational expression up here? Well, let's work off to the side a bit and just focus on that. We can split this up to a times p over rt times rt times z. This is where we bring in the expression q equals a over brt, right? Now we can manipulate that a little bit because we can see an a here, or let's use my laser pointer rather. We can see an a here, and we can see an a here. Let's see how we can manipulate that equation to say that a is equal to q b r t. And if we plug that in, we get q b r t times p over rt z. Notice that this now cancels out. We now have a b p over rt times z. We can now spot a value that is equivalent to beta. So this cleans up to a times beta over z. Okay? And when we plug that in, we can bring z down to the denominator. So let's go ahead and do that. We now have a times beta over z times 1 plus epsilon beta over z times 1 plus sigma beta over z. Okay. Now, what do we see at this point? Well, we see a lot of reciprocal z's in the denominator. So what we can do now is divide each side of the equation by z right? And notice how in the second expression we'll have multiplied by z here, and we'll have another multiplied by z. And in doing so, we'll be able to deal with each quantity in that denominator. So let's go ahead and do that. Z divided by z is now equal to 1. Well, let's zoom in a bit so I can be more accurate. 1 equals 1 over z minus b p. Oh, beta p. It's important to differentiate between beta and b here, since we, have both terms in this derivation. We cannot say that these are synonymous. Anyway, moving forward, a times beta over let's skip ahead and skip some steps. And I'll quickly explain. Remember that this z can now distribute in this quantity, and we're dividing by z again, so there's another z here that can distribute in this quantity. So we can clean up the expression a bit by saying that z plus epsilon beta times z plus epsilon beta. Oh, sorry, sigma beta. Okay. Well, this is significantly cleaned up, but we still have a rational expression minus a rational expression. How are we going to simplify that? Well, nothing more than brute force, okay? Find a common denominator and subtract. First thing we'll want to take care of is these two quantities multiplied by each other. We'll want to get it in one expression, and we'll try to condense it as much as possible so that we won't have to FOIL out 4 terms, okay? And I'll show you quickly how we do that. Well, z times z is z squared plus z times sigma beta, z sigma beta, plus epsilon beta times z times z. Now hold on. Take a look at that expression. What do we notice? We notice that each term between these two have both a z and a beta, a z and a beta. So we can clean that up really quick by factoring out the z and the beta and say that z beta times sigma plus epsilon. Okay? And then the final term plus epsilon b epsilon sigma beta squared. I really need to stop saying b. It's not b, it's beta. So that's the denominator here. Okay, and I'm gonna go ahead and clean things up a bit by saying that notice how it's 1 equals 1 rational expression, and you have 1 expression here and 1 expression here. Okay? I'm going to take this expression and move it to the other side. I can say that the denominator equals the numerator. Okay? So, we can say that the left-hand side of the equation is z minus beta p times z squared plus z beta times the quantity sigma plus epsilon plus epsilon sigma beta squared is equal to, well, this expression times 1 is just equal to that expression. And let me write that out. Well, we'll write it out in a different color. Z squared plus z beta times sigma plus epsilon sigma beta squared minus, I'm out of room. It's not ideal, but we'll go to a different line. A beta times z minus beta times p. Okay. Well, we now have a equality that's not in rational expression form. So what can we do here? What we eventually want to end up with is an expression, well, a cubic polynomial, some constant times z cubed plus some constant times, plus z squared plus z plus some constant. Okay? Anything that's not z is our constants, right? And equal to 0. And the way we do that is, well, we're going to do some more brute forcing, but we'll do it in a systematic nature. Okay? We'll set up a table with z cubed, z squared, z and constant, and then we'll organize everything, right? But we're going to need a lot more room, so let's move to the next page. While I grab that expression. And there we go. Okay. And we're going to create this table. Well, it's important to assume terms to be on left side. Okay? So, in other words, this z squared will be negative, right? And this z cubed will remain positive. Okay? I hope that makes sense. And let's set up our table. We'll have z squared, z cubed, z squared, z, and constants. And we'll go through each, and it'll be in a bit more organized nature. Okay, starting with the left-hand side, z times z squared is equal to z cubed with a constant of 1. So we'll put 1, right? And z times this expression is a z squared expression. Okay? So plus beta sigma plus epsilon, and finally z times this expression is a z expression, therefore it falls here, epsilon sigma beta squared. Okay, next we have beta p times z squared. That is a z squared expression, but it's negative, so negative beta p times this expression is a z expression, and let's write it out. Negative z beta squared quantity sigma plus epsilon. Okay. And negative beta p times this expression is a constant, okay? Because there is no z in this expression. And we can say, let's see. Epsilon sigma pressure. Epsilon sigma pressure. Beta cubed. And don't forget the negative. I believe that is correct. Okay. And believe it or not, we're done with the left-hand side of the equation. Moving on to the right, we have a zeta squared. Oh, sorry, not zeta, z squared. But it's on the right hand, and we want to get to the left hand. Therefore, it's actually -1. Okay? Then, z times beta times sigma. That's a z expression, but it's negative because it's positive on the right side. So we'll put it negative beta sigma z beta times epsilon. That is a z expression. Negative beta epsilon Or, actually, come to think of it, I don't know why I'm splitting it up into two expressions, but I can just keep it as one. Negative beta sigma plus epsilon. I'm doing more work than I should. Okay. This expression doesn't have a z, therefore it's a constant. Negative epsilon sigma beta squared. Okay? Let me rewrite this. This is why I need to be careful, because sometimes I can't even read my own handwriting. Is that an A? It is an A. Okay? Let's complete that A loop. Oh, in the right color, of course. Okay. Negative A beta times Z, that's a Z expression. It is now positive A beta. Negative A beta times negative beta P. Double negative makes it positive. Move it to the left-hand side of the equation. Makes it negative, which then equates to negative A P P beta squared. And there you have it. This tabulated form of expression is equal to 0, and this is our cubic polynomial form of the cubic equation of state with respect to the compressibility factor z. Okay, just a quick addendum. I made two minor but critical mistakes. Okay? Number one is, due to no other reason than my less than ideal handwriting, this is not an A. We got rid of A a long time ago. This is actually a Q. So, Q there. That's now a Q. And this is now Q. And another critical mistake is I had failed to see that by replacing this expression with beta, this P should not be here. This P is part of beta. Okay? So, moving forward to the cubic polynomial expression, this P should not be here. Okay? Therefore, getting rid of this P here, this is just negative beta. Okay? And getting rid of this P right here. And finally, getting rid of this P right here. With those corrections in mind, this is now our correct cubic polynomial expression in terms of the compressibility factor Z. Thank you.